All right, today we are going to be in 5.4, and this is going to be our second day in 5.4. So yesterday we talked about the product to sum formulas. And again, you don't need to memorize these, you just need to know how to use them. Today we're going to focus on the sum to product formulas, and there's 4 of them. So the first one is sine alpha plus sine beta. And this is equal to 2 sine of alpha plus beta over 2 cosine of alpha minus beta over 2. So the next formula is sine of alpha minus sine beta. And the formula is almost identical as before, except the signs change. So it's 2 sine of alpha minus beta over 2 and cosine of alpha plus beta over 2. And then there's 2 for cosine. So we have cosine of alpha plus cosine beta. And this is equal to 2 cosine of alpha plus beta over 2 cosine alpha minus beta over 2. And the final formula is cosine of alpha minus cosine beta. And this is equal to negative 2 sine of alpha plus beta over 2 and sine of alpha minus beta over 2. So this is the 4 formulas for this section. Again, you do not need to memorize these, just need to know when to use them. Notice a little different as before. Before we had formulas that looked like this. It was the quantity of alpha plus beta. Now you have 2 different functions, so make sure you can differentiate between the 2. So for our first example, we are going to just practice making sure we can use the formula. So the directions say express each sum or difference as a product. Okay, and the problem looks like this. We have sine of 9x plus sine of 5x. So looking at those formulas, so we have 4 formulas we wrote down. Since I have 2 sine values and they're adding together, we're going to use the top formula. And this is like my alpha, and this is my beta. Okay, so when we go to plug it in the formula, it's just so you have an idea of which one goes where. So the formula is 2 sine of alpha plus beta, so that means 9x plus 5x all over 2, times cosine of alpha minus beta all over 2. And now we just have to kind of condense these fractions, so I get 2 sine of 14x over 2 and cosine of 4x over 2. And last thing I would expect you to do is divide all the way. If it doesn't divide evenly, you can leave it as a fraction. Otherwise, I do expect you to divide. So we get 2 sine of 7x, cosine of 2x. And that would be it. So again, you're just looking at the formula, and you try plugging it into the formula, and you condense what you can. So let's try one more. So the next example is cosine of 4x minus cosine of 3x. So looking at the formulas again, I gave you 4 formulas at the beginning. I have 2 cosines and they're being subtracted, so I use the last formula. And your 4x is your alpha, the 3x is your beta. And the formula says negative 2 sine of alpha plus beta, so I have 4x plus 3x over 2, and then times sine of alpha minus beta, so 4x minus 3x over 2. And then we condense what we can, so I have negative 2 sine of 7x over 2 and a sine of x over 2. And because the tops of the fractions are odd numbers, I don't expect you to divide. I don't want to see decimals, so this would be your final answer. This is as far as we go. So now I would like to show you how to verify using these formulas. So we're going to do some verifying next. So again, remember verifying is you're trying to prove one side is equal to the other side. So here I have cosine of 3x minus cosine of 5x all over sine of 3x plus sine of 5x. And I'm trying to prove that all of this becomes tangent of x. So as far as the right side, there's not much to do over there. I know tangent sine over cosine, but that's not really going to get me anywhere. So we're going to work with the left side. And notice I have two different formulas. So in the top, cosine minus cosine is the fourth formula, and in the bottom, sine plus sine is the top formula. And notice in both cases, alpha and beta are the same. Alpha is 3x for both top and bottom. Beta is 5x for the top and bottom. So for the top of my fraction, I'm going to use the bottom formula, which is negative 2 sine of alpha plus beta, so 3x plus 5x over 2, and then sine of alpha minus beta, so 3x minus 5x over 2. And now in the bottom, the sine plus sine, we'll use the top formula. And that top formula says 2 sine of alpha plus beta, so 3x plus 5x, times cosine of alpha minus beta, so 3x minus 5x all over 2. So I know like this looks like a lot and messy, but once we clean things up, you're going to notice a lot of our terms cancel. So in the top, I have negative 2 sine, so 3x plus 5x is 8x, and when I divide that by 2, we get 4x, so I kind of skipped that step. For the other one, 3x minus 5x is a negative 2x, divided by 2 is negative x. In the bottom, I get 2 sine, so again, 3x plus 5x is 8x, over 2 is 4x. And then I have cosine of a negative 2x over 2, which would be cosine of a negative x. And again, like I said, you're going to notice a lot of terms cancel. So the 2's out front are going to go. I have 2's top and bottom, so they can cancel. I have sine of 4x, that can cancel. And then we think about our even and odd identities. So remember sine, the negative comes out front, but there's already a negative here. So I have negative of a negative sine x. And for cosine, the negative goes away. And we know two negatives make a positive, so now I have sine x over cosine x. And at this point, we've now proved that this is equal to tan x, because we know sine over cosine is tangent. So this is how you use the sum to product formulas to verify. So we'll pick up with this more tomorrow.